Okay, so this is our Merleau Ponty reading group. We're continuing our reading of the structure of behavior. We are picking up, I should have checked this before we started, but what I have in the notes is page 93 of the translation. Hopefully that is what everyone else has. The last couple times, so yeah, I think the last session was more, what we read last time was mostly sort of a recap of the lessons from some of the detailed analyses of experiments and so on that he had done earlier. And so some of the, I guess, lessons to learn from these analyses of experiments are that, that you can't do something like a two-step integration process. So he's already in earlier passages, he's sort of explained why you can't understand behavior in terms of these sort of simple atomic reflex structures or actions like the reflex theory would want to do. But he's also, in the next part, he's criticized these sort of accounts that try to go beyond the reflex theory by incorporating something like integration. So you would have like simple atomic sensations at the first level, and then they would be sort of integrated at the second level, or compared with each other or combined in some way at the second level. And he argues against this kind of approach that would sort of maintain the atomic character of sensations, but then integrate them into something more complex through some sort of processing later on. He argues against this kind of account essentially by showing like top-down influences on the inputs, to put it into like one formula. So like in the case of color constancy, for example, it turns out that what color you perceive, so the color sensations that you have is dependent not just on what wavelength of light is striking one particular patch of your retina, but also on the sort of grasp of the ambient illumination. So that, like the example that I've mentioned a couple times is you have a white sheet of paper. You look at it under sunlight. You have light coming in through the window, for example, during the day. The white sheet of paper looks white. Everything looks normal. But then in the same setting, if you turn on an electric light, the electric light shining on the white piece of paper gives it a sort of yellowish hue. It doesn't look sort of pure white anymore. It looks sort of a yellowy white. But then if you wait till nighttime, or you close the curtains or whatever, and the electric light is the ambient illumination, then the white piece of paper looks white again. But here, like the actual wavelength of light that is striking your retina is going to be the same. It's still the light from the lamp that it's striking the paper and then being reflected onto your retina. But there's a difference in terms of like the setting, the general understanding of what the ambient light or what the background light is in the situation. So what color you actually perceive the paper to have, or like what color is corresponds to a particular wavelength of light striking the retina depends on the color of the background light or the ambient illumination. So there's no sort of straightforward correspondence between like this wavelength of light striking this patch of the retina produces this color sensation in this part of the visual field. There's a much more complicated interaction between the light striking one region of the retina and then the ambient illumination that sort of makes the setting or the structure in which that color patch is perceived. So what this shows, or what Merleau-Ponty argues that this shows, is that you can't just sort of start from these atomic sensations like color patches and then integrate them somehow to produce like a more complex structure or a larger structure. You have to start from these existing structures, like the grasp of the ambient illumination as this kind of whole and then see how the individual color patches fit into that whole, or into that structure. And so, more in a more sort of abstract sense, what he's proposing is that we have to make sense of the idea of grasping an articulated structure as such, and not sort of grasping these elements and then putting them together into a structure secondarily. So, like in perception, we have access to these articulated structures as such, and not like these structures are not sort of a secondary product of integration or something along those lines. So that's sort of the general argument that he's drawn from analysis of a bunch of different experiments that we've looked at, and then maybe more generally as well, like this sort of notion of grasping a structure has to do with the sort of function of perception in a living being in general, right? Like living beings perceive objects and events and so on in the world, not just for their own sake, but because they contribute in some way to the life project of that being, of staying alive, finding food, finding shelter, finding a mate, reproducing, and so on. All these sort of tasks that make up what a living being does are like the reason for perceiving anything in the first place. So adapting to the opportunities and dangers that the environment presents is like what perception is for. And so like these sort of structures of the environment, of a danger or an opportunity and so on, are what we sort of primarily perceive, or what our perception is geared towards, as opposed to perception being some mechanism for like producing sensations as a result of an influx of energy onto our sense organs, and then having some sort of like inferential process to figure out what that tells us about the environment. So we want to sort of understand perception and behavior of organisms as part of the ongoing problem-solving capacity of this organism, of how it finds opportunities in its environment, how it avoids dangers, how it pursues its life project, given what the environment offers to it. So that's sort of like the bigger picture of this sort of quasi-vitalist, I guess, approach to perception that he's offering us. Okay, so with that, I guess we can jump into the text for today. So if someone could start from page 93 at the section heading "The Structures of Behavior."
I can read. The structures of behavior. The preceding paragraphs show that a reason principle, the impossibility of reducing the whole of behavior to the sum of real parts. Physiology could not achieve the reduction of behavior on the basis of cerebral functioning, as it is known by chronaxic measures, or more generally by physical methods. Inversely, it shows that it is psychological analysis of morbid behavior, confronted with the presumed extent and location of lesions, which allows us to construct hypotheses concerning the central sector. Thus, what we have just said concerning their physiological substrate only anticipates the direct examination of higher forms of behavior. And our reason for not beginning with such an examination was to show that the method, which is called physiological, refers us back to behavior. The image which Pavlov gives of behavior and the results of recent investigations must now be compared without any hypothesis concerning cerebral physiology being implied in this discussion. Since the theory of the conditioned reflex has attempted above all to explain the expansion of the reflexogenic field of the animal, the decisive point for it should be to explain the acquisition of a new and adapted mode of behavior. As a theory of learning, it joined forces with the principle of, quote, trial and error, unquote. Presented with a new situation, the animal would react by a series of attempts to which no intentional character, that is, no internal relation to the situation, should be attributed. Enclosed in a cage outside of which its food is placed, the animal would execute under the pressure of need a multitude of gestures, grasping and shaking the bars, etc., among which could be found the decisive gesture, biting or pulling the lever which regulates the opening of the door. Those of the trials which were not followed by success eliminated from future behavior, the others said and acquired. But how can the same situation evoke new trials in the case of the failure of the first? And by what mechanism are the favorable responses and only those established? Concerning the first point, the existence of multiple connections established in advance between an afferent path and several efferent paths invoked, Thorndike, which we have seen is hardly compatible with the data of modern physiology. With regard to the second point, the pleasure of the success was appealed to anthropomorphically in order to explain the fixation of useful reactions. The conditioned reflex theory provides strict behaviorism a more satisfactory explanation. After a failure, the organism undertakes a new trial because, according to the laws of reciprocal and internal induction, the points of the cortex which were inhibited until then pass to a state of excitation. If a rat in a labyrinth be trained always to choose the path marked by a white curtain, at the end of which it finds its food, and never the path marked by a black curtain, which is obstructed and where it receives an electric shock, it is because the white curtain becomes the conditioned stimulus of the positive reactions to the goal. Inversely, the bars of the cage, first example, and the black curtain in the second, give rise to a conditioned inhibition. The privilege of the acquired response will be confirmed by reception, since coming at the end of a series of experiments, and sometimes at the very beginning, it is more frequent than any of the others. Learning and the adaptation of behavior do not, properly speaking, achieve anything new. They only transfer to certain stimuli the power of releasing certain movements, the motor conditions of which are considered as given in advance. The development of behavior consists only in the different association of pre-existent elements. So, as I understand what he's doing here, he's looking at whether or not reflex theory plus this idea of conditioning can explain learning behavior. And just as reflex theory generally sees the organism as passive and just, operating on a fixed repertoire of behaviors in response to more or less fixed stimuli, this conditioning theory holds that a natural stimulus response pair can be sort of transferred to a new stimulus if that new stimulus is habitually associated with the response that was associated with the original stimulus. But he's going to show why the problems that this theory runs into.
Yeah, exactly. Just to sort of recap this conditioning theory. So you have the famous example is the Pavlov's dog experiment. So the dog has an unconditioned response to meat powder. So if you present meat powder to a dog, it will start to salivate. It doesn't have to learn how to do this. This is something that dogs will do without any training. And then if you continually ring a bell every time you present the meat powder to the dog, and then after a certain number of trials of repeating this, you just ring the bell without presenting the meat powder, the dog will still salivate. So now this unconditioned response, the salivation, has been transferred through conditioning onto this other stimulus, the ringing of the bell. And this was, of course, a whole research program of trying to figure out how many trials does it take before this transfer happens? What different types of stimulus can you transfer the response to? Can you make a chain so that the ringing of the bell is then later associated with flashing a light or whatever, and then will the dog salivate after just flashing the light, and so on. So all these different sort of variations were studied. And so the types of questions, we'll see this in the next reading, but the types of questions are, there's lots of different questions that this type of explanation raises. So one would be first of all, is this even sufficient to explain, this sort of very simple behavior of salivating that the dog exhibits in the Pavlov type experiments is this really something we can use as a model for much more complex and, in particular, goal-directed behavior of an animal? Something like, figuring out how to open the cage, for example, this is something where the animal has a clear goal, like getting the food that's outside the cage. They have a strong impulse towards reaching that food. And the question is, can we explain the animal's capacity to learn how to open the cage just in terms of some sort of random attempts to, or just, producing random behavior and then reinforcing the few instances of behavior that actually lead to a positive reinforcement, namely getting the food. So, like, one problem with this would be, if we assume that the animal is just sort of a repository of these fixed behaviors, and then we assume the situation is the same, so like the food hasn't changed, the cage hasn't changed, etc., then it's not clear why the animal, like, how do you explain that the animal produces a different behavior after the first trial that was unsuccessful? So, like, if the animal is the same and the situation is the same, and those are the only factors in this whole explanation for behavior, then how is it that the animal produces a different behavior after the first one fails? So, this is already, a problem. Why where does this new behavior come from in the first place? And then he mentions also this, like, sort of problem having to do with anthropomorphism related to this notion of pleasure. So, like, some earlier forms of explanation would say the animal tries a bunch of random behavior. Some of them, most of them don't actually do anything. One of them happens to produce the desired response by opening the cage and allowing the animal to reach the food, and then the animal has a feeling of pleasure, and this pleasure sort of reinforces the behavior that led to that response. But then this is, again, just sort of an anthropomorphic explanation. So, like, we recognize in our own lives that doing something that leads to the result that you wanted is pleasurable. We have this experience that we associate with a successful execution of some sort of behavior, but we're just sort of transferring this onto the animal and then saying this is the explanation, but it doesn't really tell us anything more than the fact that the behavior is successful. In, like, the appeal to this experience of pleasure is just sort of a more descriptive way of saying that the trial succeeded. So you're essentially saying the animal learns this behavior because it was successful, and so and then you just sort of add a more colorful language when you say the pleasure is what leads to the learning. So yeah, it doesn't really, like, tell us anything more than what we already knew just by describing the fact that the animal learned something. So, like, if we want to give something more substantive, give an actual explanation of how this learning process happens, we can't sort of appeal to, like, we can't appeal to terms like pleasure that we sort of draw from our understanding of human behavior and our own experience. So we can't, like, use these, we can't just sort of transfer these onto the animal model and explain the animal in those terms without, like, giving any more explanation of what the relation of this pleasure and the learning process is. And then so Bats has put it in the chat here. This is a good comment. So if our goal ultimately is to explain human behavior, but our explanation of animal behavior, which is supposed to be like the simpler case that we use to sort of build up our explanation of human behavior, if our explanation of animal behavior is, like, drawn from human behavior and sort of transferred from human behavior, then when we come back to that goal of explaining human behavior, we are just sort of going in a circle. We've like started from human behavior, transferred that sort of understanding onto animal behavior, and then we sort of try to transfer it back to human behavior, but then we're, like, back to our starting point and we haven't really gotten anywhere. The only way that studying animal behavior will help us understand human behavior is if we sort of have more content in our understanding of animal behavior than is, like, just sort of transferred from our understanding of human behavior. So we have to use some sort of explanatory model or explanatory resources in the case of animal behavior that are different than what we already understand about human behavior. Otherwise, we are not really getting anywhere. And it's also maybe just another point on this. It's also interesting to note that like these authors, using the sort of reflex theory and the conditioning approach and behaviorism in general, were presented themselves as being like the very sort of scientific and physiological approach to behavior, as opposed to sort of vague appeals to introspection and these other types of unscientific approaches to behavior. But we see, through this kind of criticism that, this supposedly very scientific approach to behavior ends up having to rely on, just a sort of transfer of our pre-scientific understanding of our own behavior and just sort of, re-describing that understanding or applying that same understanding to animal behavior, but like, put into this scientific terminology. So yeah, just the fact that that you're doing experiments on rats or mice or whatever, and the fact that you use like scientific sounding terms and so on doesn't necessarily mean that you're doing something more scientific than just sort of looking at human behavior and trying to understand human behavior in its own terms. So like, yeah, there's a sort of appearance of scientificness or scientificity, or if that's a word. Just like, the fact that you're doing experiments is sort of here kind of an ideological projection of like rigor onto your studies that is not necessarily justified by the actual theoretical value of these experiments. Okay, so let's go on to the next bit. So if someone can read from 94, I believe we're at, but is the frequency?
Yeah, I can read. Okay. But is the frequency of favorable responses sufficient to explain why they become rooted in behavior? Is it not, on the contrary, because they are preferred that they become durable acquisitions? It is not true that to say that they are produced more often than the others in virtue of the very conditions of the quote-unquote trial, which, in the laboratory as in life, comes to an end only at the moment when favorable responses do occur, and as soon as they do. It is forgotten that fruitless trials, in experiments like those of Thorndike, are repeated many times before the animal turns to other means. Moreover, frequency cannot intervene in inhibition, which is acquired once and for all with regard to dangerous stimuli. Conditioned inhibitions should become weakened by the very fact that they anticipate the return of painful experiences, and one should see quote-unquote stupid reactions reappear as the training progresses. Finally, favorable responses seem to be able to be established after a single test, as is adequately shown by the sharp rise of the curves in motor learning. These facts suggest the idea that the value of positive or negative behavior would intervene in some manner in its fixation. But how can this intervention of values be represented? What is it in the organism which can, as it were, appreciate them? Let us return to the acquisition of behavior in order to determine whether it can be understood as an accidental connection. Behaviorism made its task easy by supposing, in our example, that the lever which regulates the door can become the conditioned stimulus, not only of reflexes of prehension and mastication, which take place in the presence of the goal, but also of the manipulations which have preceded the opening of the door. In the same way, behaviorism is content to say that the white curtain becomes the conditioned stimulus of the quote-unquote positive reactions, thereby confusing, under the same name, reactions to the goal, which could indeed be evoked by it after training, and reactions preparatory to the solution which it could not establish. In reality, the difficulty is one of principle. The conditioned reflex theory presents stimulations and responses which succeed each other in an organism like a series of events external to each other, and between which no relations can be established other than those of immediate temporal contiguity. The manipulations which the animal executes on the lever are in themselves only the effects of cerebral mechanism. They will in fact bring about liberation and success, but they have no relation whatsoever to the quote-unquote perception of the food, except perhaps insofar as it awakens the need and thus provokes a state of agitation favorable to the activation of pre-established conditions. But on this point, the useful manipulations are in no way privileged. They owe as much or as little to the goal pursued as the useless attempts which have preceded them, and it would be necessary that the goal, because it had been attained, be capable subsequently of stimulating them again. Any prospective relation between the preparatory attitudes and the goal is eliminated. One would like the goal, by a retroactive effect, to be able to bring back the conditions which have permitted its attainment. Do I continue or do I stop here?
Yeah, maybe read the next paragraph as well.
Okay, yeah.
Thanks.
But if learning is really only a particular case of physical causality, it is difficult to see how the order of temporal passage would reverse itself, how the effect could become the cause of its cause. For the quote-unquote perception of the lever or the goal to bring back the useful manipulations, it is not sufficient for them to have preceded it in objective time. The attitudes which will lead to the goal or their physiological substrate must possess, either before the animal has quote-unquote tried them or after they have succeeded, some distinctive property which designates them for success and integrates them into the quote-unquote perception of the goal. It remains to understand the relation which is established between the goal and the preparatory actions, giving a meaning to the multiplicity of elementary movements which the latter combine and making of them an act in the proper sense of the word, a new creation after which the behavioral history is qualitatively modified.
Right. So here we have sort of a more general criticism of this form of explanation in terms of the transfer of conditioning. So again, we're thinking the type of learning process that we're thinking of is, you have an animal in a cage, you have some food outside the cage, and then the animal tries a bunch of different things and eventually figures out how to open the cage and reach the food. And then the question is, how do we explain the learning process so that, like, the next time you put the animal in the same cage, it will, use the correct behavior to open the cage and not try all the other behaviors that didn't lead to the results of opening the cage. And so, like, if your explanation is just in terms of frequency, that, like, the behavior is reinforced through repetition, then you actually should get the opposite results of what you do get. So, like, all the unsuccessful trials are repeated many times, and then the successful trial only happens once. Like, you only need to open the cage one time to get to the food, whereas you might try all the different unsuccessful ways of getting through the cage or getting around the obstacle many times. So if it's just a question of frequency, then the unsuccessful behaviors should be reinforced, and the successful one would not be reinforced, which is obviously the opposite of what we observe. And so it's in this type of situation that you would, like, appeal to something like this pleasure or some sort of positive value of the goal. But again, this is sort of an anthropomorphic explanation. And then the sort of more general question is, like, if we assume that each of these behaviors is this sort of self-contained whole, this, like, sort of atom of behavior, then how is it that the reaching the goal sort of travels back in time almost to reinforce the behavior that actually led to this positive results? So, like, the animal tries behaviors A, B, C, nothing happens, and then it tries behavior D, and that leads to the cage opening, and then subsequently leads to being able to eat the food. But at the moment when the food is being eaten, the behavior D that led to the result is not there anymore. Like it doesn't exist anymore. It's in the past. So then the question is like, what exactly is leading to the relationship between behavior D and the positive results? If these are sort of two, atoms of behavior or self-contained wholes, that bring about that somehow get connected to each other. And so like just like Angus has said in the chat here, so like what we find in these experiments, for example, that the animal tries behaviors A, B, and C with no results, and then it tries D, which is successful, and then it gets the food, and then you put it in the same situation, it doesn't go through A, B, and C again, it just does D. It doesn't, so like how does the animal sort of understand or know that D, the behavior D, is what actually opened the cage and not the whole sequence A, B, C, D? There's nothing sort of inherent in the situation that would tell the animal that it can just do behavior D and not do A, B, C, and then D in order to bring about the desired result of reaching the food by opening the cage. So like how do you sort of carve up the whole sequence of behaviors into the one element or the one action that brings about the desired results, and discard all the other preceding behaviors that were unsuccessful. There's nothing sort of inherent if A, B, C, and D are each these sort of atoms of behavior. There's nothing that would say that the successful result should transfer its capacity of or its positive value onto D and not onto C and D or A, B, and D or any other combination that includes D. So we haven't really gotten very far just by saying that there's a sort of transfer of this positive value onto D, because we still don't know why the animal would choose to perform or would figure out that D is the right the necessary behavior to perform, and that A, B, and C are not helpful in trying to achieve the goal.
This reminds me, it's similar to, I think we talked about this in a previous session, but the dog and the bell example. I think Merleau Ponty says that maybe in a highly controlled laboratory setting, you may be able to explain this conditioning, this transfer of the stimulus and response to, or a transfer of the response to a different stimulus. But in the real world, there would be so many simultaneous stimuli when the dog is presented with food that it just seems like there's this total direction to conditioning that can't explain why the dog wouldn't associate any number of contingently present stimuli with eating, and not just the ones that bring it back to the food when it needs to eat.
Yeah, and this is like a real issue when you're designing experiments for animal psychology. Like in experiments with human subjects, you can just like tell them or what they're supposed to do, or ask them what you were doing when you did this trial. But of course, with animals, you can't do that in the same way. And so, as the experimenter, maybe you want the animal. You're looking into can animals, can these dogs, for example, can they distinguish circles from triangles? Maybe that's what you're interested in. And so you present a bunch of circles to the dogs and a bunch of triangles, and you sort of train them to press one button in one case and a different button in the other case, or whatever it is you're trying to, whatever technique you use to try to figure out whether the dogs can distinguish these two shapes. But often what happens in this circumstance is that the dog is might succeed in the sense that it presses the button that you think corresponds to the circle whenever there's a circle present, say like 90% of the time or whatever. But it turns out if you are more careful about evaluating what the dog is responding to, that it's not necessarily the shape that for you is the sort of salient aspect of the situation, but it's something like the total surface area of the display that's illuminated. So maybe the circle is bigger in surface area than the triangle, and the dog is just going, okay, this display has like, X% of the surface area is illuminated, therefore I press this button, or this display has Y% of the surface area illuminated, so I'm going to press this other button. And so the dog is not responding to the shape, which you perceive and think is important. The dog is responding to the percentage of the surface area that's illuminated. So like you have to be very careful in controlling for all these other factors, like the percentage of the surface area that's illuminated, or which side of the display the shape is presented on, and so on. All these different things you have to try to account for any other variables that the dog might be responding to, as opposed to the one that you think is important. And so this means that doing these animal experiments is much more complicated than you might think. And the results, because you have to control every single variable like that, the results are much more limited than you might hope as well. Like instead of saying dogs can recognize circles, you have to say something like if you control the surface area of illumination and all these other factors, then the dog can distinguish between circles and triangles. But it doesn't necessarily tell you about dogs' capacity to distinguish circles from triangles in all kinds of other settings. And so like when you do like more sort of naturalistic studies of whether dogs can distinguish different shapes from each other, the dog might be using all sorts of different aspects of the situation, including what percentage of the surface area is illuminated, to distinguish the different shapes from each other in it could be quite different ways than the way that humans might distinguish the shapes from each other. And it's hard to, just from looking at the dog's behavior, to figure out, which aspect of the situation is the dog sort of responding to specifically when it, learns what we would say as like distinguishing circles from triangles. So like, and like whenever you have these more sort of natural settings where it's not just these very controlled experiments with a display and a button or whatever, but it's solving a problem to open a cage to reach food or something like that. Because there are so many factors, so many different aspects of the situation, it's pretty much impossible to say which element of the situation it is that the dog is learning to respond to, and so without that you can't really develop this stimulus response analysis of the situation. So Bats has put a question here in the chat about whether we humans might be responding to difference in surface area when we recognize shapes, and so this is also a problem in human experiments. So sometimes what we sort of are aware of in terms of what we think we're responding to is not necessarily the factor that is sort of really important in determining whether we're capable of performing a certain task or not. So like there are different approaches to try to figure these things out. So one element is or one approach to this is using reaction time as a sort of proxy for like how easy or difficult it is to perform a certain discrimination task. So like if you do like a very sort of easy task where it's like you have one shape is like a big red circle and the other shape is a small yellow triangle, and so here the shapes are different, the colors are different, the sizes are different, everything is different. So these two and you have to distinguish between these A or B. This is a very easy task to perform, so we would expect people to respond very quickly in like if the task is press this button if it's a big red circle, and then press this other button if it's a small yellow triangle. This people should respond very quickly to this kind of easy discrimination task. But if it's something that's much harder, if it's like two yellow triangles that are like 5% different in size, and you have to say is this the bigger one or the smaller one, then we should expect people to A, make more errors, and B, take longer to actually make that discrimination. So this is like one sort of approach to try to figure out what it is exactly that people are responding to in the situation, analyzing the response time when you sort of vary the different aspects of the situation. But here again, like if you just ask someone, what is it about the situation that you're responding to, they might not be able to tell you, or what they do tell you might not be very reliable. So you have to sort of abstract from your own understanding of your behavior, or the subject's understanding of their own behavior, and then sort of look at that behavior from outside, and look at it in terms of this reaction time, and then try to use that to reconstruct what it is about the situation that the person is responding to.
I can read the next page or so.
Yeah, sure. Go ahead.
We're rigorously described, right?
Yes. Yeah, thanks.
Rigorously described, moreover, does not appear to be the addition to old forms of certain predetermined connections between such and such stimuli and such movements, but rather to be a general alteration of behavior which is manifested in a multitude of actions, the content of which is variable and the significance constant. Conditioning could establish only useful responses which are like those produced the first time. This is not what we observe. A cat trained to obtain its food by pulling on a string will pull it with its paw first successful trial, but with its teeth on the second. If, as often happens, the first favorable attempt has been mixed with useless movements or partial errors, these accents will disappear from subsequent responses. Thus, to learn never consists in being made capable of repeating the same gesture, but of providing an adapted response to the situation by different means. Nor is the response acquired with regard to an individual situation. It is rather a new aptitude for resolving a series of problems of the same. It is known that in children, the acquisition of differential behavior with respect to colors is slow and difficult. When the child has succeeded in distinguishing red and green and naming them correctly, what is acquired is not, properly speaking, the discrimination of these two qualities as such. It is a general power of comparing and distinguishing colors. All pairs of colors benefit from the distinction of red and green, and differential behavior progresses not from one to the other, but by a finer and finer discrimination with regard to all of them. I don't know how to pronounce this name. In Buitendijk's experiments, this systematic learning is discovered in fish. If one accustoms sunfish to seeing first black and then white bread, and once the habit is acquired, one mixes pieces of chalk with the white bread, a differential behavior with regard to the chalk and the bread as visual stimuli is acquired little by little. If one then mixes pieces of black rubber with the black bread, a differential behavior is again acquired after a period of quote-unquote disorientation, but much more rapidly than in the first case. If one comes back to white bread, the readaptation is made after a much shorter delay. Thus, the inhibitions acquired with regard to the pieces of chalk made it possible for the animal to acquire inhibitions more rapidly with regard to the pieces of rubber, and inversely. It is not to a certain material, therefore, that the animal has adapted, but, to speak a human language, to a certain kind of deception. The effectively acquired learning could not be understood as an association between such and such a visual stimulus, the proper color of the chalk and the rubber, and the negative result. It is an aptitude for choosing, a, quote, method of selection, unquote, which is established in the animal. So yeah, I don't think doesn't seem like there's anything radically new in these couple of paragraphs. But this example of the fish is interesting, that fish can learn that you are trying to trick them. But obviously this is something that can't be, if it's just the transference of of anatomic behavior, it wouldn't make sense that the fish catches on more quickly that you're mixing rubber with its food when you change the color or the type of fake food.
Yeah, so I guess here what's a bit different than the previous couple paragraphs was, so the question before was like, on the response side, I guess, in terms of why or what is the mechanism through which the animal selects the useful behavior, or the behavior that actually does help to bring about the goal, as opposed to all the other behaviors that preceded it. And then now the question is on the sort of stimulus side of like, which stimuli exactly are capable of bringing about the behavior. And it turns out, I mean, this is sort of obvious if you think about it, but like animals don't learn the very precise, exact set of stimuli that are presented to them. They actually learn to generalize in some way, and it would be kind of counterintuitive to call something learning if the animal only ever learned to respond to the exact stimuli that you presented it with, right? If in the Bell, the Pavlov dog experiment, if the dog only ever learned to respond to a bell that is ringing in exactly this way, and every other element of the situation is the same, but then if you took it to a different room and you rang the same bell, the dog would just not respond. We would say that the dog hasn't really learned the association between the bell and the food. They've learned some much more detailed association between this particular bell in this particular room and food. But we find, of course, that animals learn much more general association. So if you do this experiment with a dog and you take the dog to a different room, they will most likely still salivate in response to the bell. They've learned the association between some sound that resembles this bell in general and the food in general, but not some very precise response to this exact temperature in this exact illumination in with this sort of smell and so on. So there's learning, we only describe something as learning if there is some sort of generalization, and if it requires every circumstance to be exactly the same, then it's hard to this is not really what we mean by learning in general. It's something, I don't know, more like a triggering of a behavior, but it doesn't sort of meet the criteria for what we normally describe as learning. And the example with the fish is interesting because it shows that so fish, we don't sort of tend to think of fish as being particularly smart. At the same time, the fish are learning, not so first they, have the white pieces of bread and they learn, white stuff floating in the water is tasty or whatever. And then you start mixing in chalk, and then they, learn to differentiate that not all the white stuff floating in the water is tasty. Some of it is not good. And then you sort of switch up the experiment and you start giving black bread, and then the second stage you start mixing in black pieces of rubber. They learn much more quickly that not all the food is good. So what the fish has learned from the first set of experiments with the chalk is not just to distinguish chalk from white bread, but good food from bad food or something like that. So they've generalized much more than exactly what is presented in the experiment. And it's only because of this generalization that we can say that the fish has actually learned something, as opposed to just having a very sort of mechanical. Yeah, exactly. If someone sort of switched out half your food with rubber, you would probably, start to question whether this is exactly, is this somewhere where I want to be eating, for example. So the fish has a similar response. And yeah, so Batz has pointed out that, with pets, who are, experts at studying human behavior and responding to different patterns, often they can, figure out these patterns even better than we can, or at least as well as we can, where there's certain phenomenon, either it's their food, and they know that when you do action A, that means you're about to get the food, and so they get excited, and they sort of learn to connect whatever behavior. It could be completely separate from the food, but they connect it with the food, or it could be something that they don't like, and then they figure out, whenever the person does this, it means that something bad is going to happen. So they start to respond to that. One example I'm thinking of with my parents' dog, I used to take him outside sometimes in the backyard. So I would put on my hat, and then he would get all excited and be all happy that he's going to go outside. But then if I would pick up my knapsack and put on my hat, he would realize that I wasn't going in the backyard. I was leaving the house. So that means he wouldn't get excited. So if he sees the knapsack and the hat, then he doesn't get excited. So he has learned he's figured out which situations involve going out in the backyard and which ones don't. So it's like much more sophisticated learning as opposed to just a mechanical response to like a visual stimulus of the hat being on my head or something very straightforward like that. So there's like what exactly animals are capable of learning is usually much more sophisticated and differentiated than these very mechanical stimulus response associations. Even when you start adding like conditioning that can transfer the response to the stimulus. And this learning capacity, like with dogs in particular, it's pretty incredible. Like the kinds of things they can learn. Like there are many people who suffer from seizures, for example, who have a dog that is trained to recognize the precursors of the seizure. So the person themselves might not actually know anything. Like they don't know what's going on. And the dog, has a certain signal that they are trained to give when they recognize these precursor signs of a seizure, and then the person can lie down or take measures to protect themselves so that they can, that they won't be injured in the seizure. So the dog is, responding to, probably no one knows exactly what signs, but something about the person's behavior. Very subtle aspects of the behavior. The dog has learned to connect this with the seizure, and then to perform a certain behavior that serves as a warning, and then the person can respond in an appropriate way. And so, like the dog's capacity to recognize these precursor signs is more sophisticated than our own like human capacities, including like most sort of technical devices that we use for recognizing these kinds of things. So it's very like dogs in particular in relation to human behavior are capable of like extremely subtle learning that even surpasses like the kinds of learning that we are capable of in this case. Okay, we can go on to the next bit. I'll read a page or so. Facts of habit transfer would confirm this interpretation and the general character of all learning. It is true that the conditioned reflex theory does not necessarily suppose that learning is directed to the individual characteristics of the stimuli and is translated by the exact repetition of the movements to which the first favorable experience has given rise. The acquired conditioning can be condensed and the act abridged because each of its phases becomes, by repetition, the conditioned stimulus of the following one. It is precisely the behaviorist school which has brought to light the quote-unquote abstract character of certain animal reactions. The adequate stimulus of the reactions of the spider is neither the visual aspect of the fly nor the noise by which its presence is announced, but only the vibrations which it communicates to the web by struggling in it. This accounts for the fact that if a fly is put in its nest, the spider does not treat it as bait. Its instinctive behavior is not a reaction to the fly, but a reaction to a vibrating object in general. It would be initiated just as readily by placing a tuning fork in the middle of the web. Moreover, in almost all species, the very structure of the receptors determines an automatic quote-unquote abstraction in the same manner. Far from manifesting an activity directed toward the essential, these general reactions would rather be comparable to the stereotyped behavior of the demented person who does not take into account the details of the situation because he no longer perceives them. But this is precisely the question. Is it possible to explain in the same manner the stereotyped behavior or the quote-unquote absurd errors of the animal which attempts the same solution in essentially different situations when they have a single common trait, and inversely, no longer has the use of its instinctive powers if the situation is the least bit unexpected, on the one hand, and on the other hand, the flexibility of habits which are equally efficacious in the face of materially different situations, provided that they have the same meaning. This would be to confuse the universal and the abstract. Quote-unquote absurd errors are encountered in Köhler's observations, for example, especially when the animal is cold, tired, or too excited. Such errors bring more clearly to light the originality of quote-unquote true solutions. When the problem is for a chimpanzee working through a grill with a stick to maneuver a piece of fruit placed in a box toward itself, and if it is arranged so that only the upper part and the side of the box opposite to that of the animal is open, the animal will most frequently begin by pulling the fruit directly toward itself as it did in other more simple experiments. But this time, the side of the box placed between the animal and the goal does not allow it to succeed. The first movement, which represents a blind perseverance, is to be contrasted with the quote-unquote good solution, which can be obtained if the opening through which the goal is accessible had been placed laterally. Here, the least quote-unquote intelligent monkeys succeed immediately, even though the experiments to which they had been previously submitted had only taught them to execute these detours by themselves, or to make use of a stick without an obstacle. In the first case, we are dealing with a reaction which retains from the situation only its vague resemblance to prior situations and neglects the precise data of the present problem. It is to actions of this kind that the conditioned reflex theory applies. The presence of certain quote-unquote stimuli, the goal, the bars of the cage and the stick, evoking the movements for which they have become the conditioned excitants. In the second case, on the contrary, even though the problem is different from those which the animal has encountered until then, the monkey's behavior is related to that in the situation, which makes it a new form of already quote-unquote known problems. If, instead of considering positive habits, we were now to analyze the inhibitions created by experience, the demonstration would be still easier. It is not the violent reactions which follow a painful experience which are established in the behavior of a child, but reactions of protection which, although they have the same meaning, do not have the same appearance. In the presence of a flame, a child who has burned himself will not repeat the sudden withdrawal of the hand which the burning evoked. This indicates that learning is not a real operation, not a correlation established between two individual realities, a certain stimulus and a certain movement, which would not be modified by their association. The conditioned stimulus acts only as the representative of a whole category of stimuli, which have become reflexogenic along with it. The original response movement is established only as a particular instance of a general aptitude, which can vary around the same fundamental theme. The true stimulus is not the one defined by physics and chemistry. The reaction is not this or that particular series of movements, and the connection between the two is not the simple coincidence of two successive events. There must be a principle in the organism which ensures that the learning experience will have a general relevance. Right, so this is, again, sort of pointing out the capacity to learn general sort of response or a general understanding of a situation as opposed to a very specific response to a very specific set of stimuli. And he points out here that there's, there are cases where animals will respond to a very, sort of in a very stereotyped way to certain aspects of the situation. So like his example is the spider that responds just to the vibration of the web, and it will respond even if you put a tuning fork, a vibrating tuning fork in the middle of its web. So it's not, the spider here is not sort of grasping that there is a fly in its web. It's just sort of responding in a very automatic way to vibrations, and it produces an inappropriate response if you produce vibrations in a different way other than having a fly being caught in the web. But Merleau Ponty here points out that this is very different than the situations where the animal does produce an adaptive response. And it's sort of an open question, or you can't just assume that you can explain the adaptive response in terms of this very simple stimulus response association that is suitable for these situations of inappropriate responses. So in many situations, and it depends on, of course, on the particular animal, the particular situation, the structure of the experimental setting, and so on. In many situations, the animal is capable of grasping something about how the situation is set up and responding in an adaptive way, even if it hasn't encountered this exact setup before. So like here, the experiment with the chimpanzees is not 100% clear to me just from this description, but the idea is that you train the chimpanzee to grasp a piece of fruit using a stick, through the bars of its cage, and then you present a similar situation, but this time there's a box between the fruit and the cage, so that the movement of just sort of using the stick to drag the fruit towards the cage is not successful anymore because there's the wall of the box in the way. And it turns out that chimpanzees are capable of learning very quickly how to avoid the obstacle, even though they've never actually performed this task before. So here we see that the chimpanzee has it's not just the case that a very specific set of movements of manipulating the stick to drag the banana towards the cage. It's not just that they've learned this very specific set of movements in response to a stimulus of seeing a banana. What they've learned is something about like how you can use a stick to grasp something that you want and bring it closer. And so they figure out very quickly that if I want to do this and there's an obstacle in the way, I have to drag the banana in a different direction and move it around the obstacle before I can bring it towards me. So it's a much more general and much more structured grasp of the situation. It's not just the case that this set of movements of muscles that bring about the manipulation of the stick has been associated with the perception of a banana. It's instead that the chimpanzee has grasped the structure of the situation where the capacity that the stick has to extend my reach and the obstacle that is blocking the banana from being dragged towards me, like all these sort of elements of the situation are sort of grasped together so that the correct response of dragging the banana around the obstacle is now learned very quickly. So yeah, here this is just obviously it's a fairly simple example of learning, but still even in this very simple example, the animal demonstrates that what they learn in the preceding trials is not a very mechanical association between a certain set of stimuli and a certain set of responses. It's instead this sort of structured understanding of the situation.
Yeah, the comment about the child learning from the experience of the flame being much more complex than simply learning to, put his hand away once he's being burned. It's one of those things that is really obvious in retrospective, right? But at the same time, I don't think I had ever really thought about it in that way. In fact, in my mind, that was kind of a, I guess, very basic example of behaviorism or behavioralism, where you learn from the experience, you get conditioned or whatever. But of course, it's a much more general form of learning that is taking place here. As he said, even though they are related, it's a different kind of behavior, right? The child learns not to put his hand in the first place, in the flame. So yeah, I thought that was one of those obvious and retrospective things that had completely flew by, for me at least, before.
Yeah, exactly. So if you have a very strict form of behaviorism, and you have this sort of process where the child puts its hand near the flame, and then gets a painful stimulus and has a sort of negative reinforcement of that behavior. What should happen in future is that the child would repeat this movement of withdrawing its hand from the flame. It should sort of learn, if I put my hand near the flame, then I should withdraw it. But that's not what the child learns, of course. The child learns not to put its hand in the flame in the first place, and it learns to avoid the painful stimulus. And this is not that the child is especially intelligent. This is something that many other animals will learn as well. Most animals will learn from even a single trial or a very small number of trials that involve a very painful stimulus, like a flame or something like that. They'll learn to avoid the stimulus as opposed to just performing the behavior and then withdrawing. So here, what these animals are learning is not just that if I receive this painful stimulus and then I perform this withdrawal behavior, then I can make the painful stimulus stop, which is what a very strict behaviorist explanation would lead us to expect. What the animals learn instead is that this type of stimuli, a flame or whatever, is something I can, or this type of phenomenon is something I can avoid, and then I don't experience this painful stimulus. So they've it's not a especially sophisticated form of behavior of learning, but it's a grasp of the situation and a sort of preventative learning as opposed to just a responsive learning of this motor behavior leads to the cessation of the painful stimulus. And all these examples in this part are all related to this idea that I mentioned in the intro about how behavior has to be understood in terms of the life project and problem solving of the organism. So it's not just the case that you have these sort of atomic behaviors that somehow get associated with each other through repetition and so on. Instead, you have some sort of integration of behaviors in terms of the problem-solving capacity of the organism trying to adapt to its environment and take advantage of the opportunities and so on. So certain phenomena that it encounters, it will experience as having positive value in terms of achieving goals and realizing its projects, solving problems, and so on. Other phenomena will be experienced as negative, as impeding or preventing the achievement of goals. And it's this kind of valuation of these phenomena that is sort of involved in this learning process of generalization. So an animal learns to solve a problem insofar as it understands or grasps how different aspects of the situation are responsible for either bringing about or preventing the achievement of a certain goal. It's a much more structured understanding of the situation, and it involves this sort of valuation of this is good for me or bad for me in terms of the types of problems that I'm trying to solve. Okay, we can go on to the next bit if someone can read from If These Observations.
I can read again. If these observations did not impose themselves on psychologists earlier, it is doubtless because the problems presented to the animal in the older experiments were not favorable to true learning, as Kohler and Kafka have indicated. If the opening of a cage is made to depend on the manipulation of a lock or even of a lever, the relation of the preparatory movement to the result can only be one of simple succession, since the mechanism of the lever or of the lock is not visible from the cage. In addition, it involves connections that even man is not always capable of mastering. In the same manner, the choice of a white or black curtain for marking the entrances of a labyrinth is completely arbitrary. Thus, these are not the proper experimental conditions for bringing to light an internal relation between the goal and the acquired responses. And one should not be surprised if the animal proceeds by trial and error in situations of this kind. But even in this case, the empiricist theory of learning is not verified. As soon as there is learning, it is necessary that a relation be established between the signal, the preparatory reaction, and the access to the goal, which makes the ensemble something other than an objective succession of physical events. Chimpanzees who do not know how to build can nevertheless place cases on top of each other in order to attain a goal. But the grouping always remains very unstable and is utilizable only by an animal like a monkey, which is adroit in compensating for the oscillations of the structure by its own movements. The monkey proceeds by blind trials, setting a case on its edge, for example, and starting over again each time the edifice falls down without giving up. Thus, the trial and error schema applies here. But there is also no learning. Clumsiness of the animal is definitive. Thus, the development of behavior would never find its explanation in the contiguity realized by experience between such and such a situation and such favorable response. The decisive factor lies in fortuitous contiguities are utilized by the organism in the elaboration which the organism makes them undergo. If it were otherwise, it is difficult to see why all species of animals, as soon as their bodily structure included the receptors and permitted the required gestures, would not be apt at every kind. The difference between absurd errors and good solutions does not lie solely in the specific nature of the sensory receptors and the effector apparatuses, since success and failure are found with respect to the same problem in the same species, and in the behavior of the same animal depending on the moment and the degree of freshness and fatigue. In reality, it is never the trials by themselves, by this we mean the visible movement, which can contribute in any way to the acquisition of a habit. These trials must occur in a organic framework which gives them meaning and efficacy. They presuppose a, quote, sensory motor a priori, unquote, practical, quote unquote, categories which differ from one species to another. Even when the nature of the problem posed demands a series of prior explorations and excludes an immediately correct solution, these quote-unquote trials always have a systematic character. A rat into a labyrinth will follow the general direction of the initial elements, everything happens as if the animal adopted a quote-unquote hypothesis, which, quote, is not explained by the success since it is manifested and persists before the success can confirm it, unquote. Clearly, it must be accepted that what is tested here is not just any series of independent choices, but a definite quote-unquote path, each part of which is determined only by its relation to the direction of the ensemble, by its participation in the law of the whole. After the complete exploration of the labyrinth, inhibitions are also manifested in a systematic order. Impasses which are parallel and in the direction contrary to the general direction of the goal are the first to be eliminated. Then those which are perpendicular to the direction of the goal, and finally those which are parallel and in the same direction. Quote, the first explorations followed by a sanction at the end have the effect of classifying the alleys according to their relation to this general direction, of affecting them, as it were, with a particular vector, unquote. Yeah, I don't know if I understand this point about practical categories or sensory motor a priori, but this point about the rats in the maze, I think what he's saying here is that it's not the attempt to solve the problem of the maze doesn't just happen at random. There's a kind of polarization. Like the rat has a sense of the direction of the goal. It eliminates the paths which are in the opposite direction where it believes the goal to be first. And so, again, this is something that can't be explained by thinking of its behaviors as just a repertoire of responses indifferently triggered by stimuli.
Yeah, I'm not 100% sure about what he means here by sensory motor a priori or practical categories either. But I think the idea is that, there's this sort of prior structure to the, I guess you can call it like behavioral field, in the sense that the set of behaviors that the animal is capable of is not just sort of an indifferent repertoire of behaviors that can each be associated with any stimulus in any way. Instead, what we find is that certain behaviors are preferred, or a certain response is preferred to a given type of stimulus, and this is sort of a pre-existing structure that the animal brings to solving a problem, as opposed to being sort of a blank slate. And so, in the case of these rats, for example, sensory motor a priori of heading towards the food or whatever the goal is, this is something that the animal already sort of brings to the problem. It already understands how to navigate through a course that might not be a direct path towards the goal, but it understands how to orient itself in relation to the goal and determine, am I approaching the goal or moving away from it, for example. So this is something that the animal already has, this capacity that the animal already has before it starts to solve the problem of navigating this maze. And so it's only because it has this capacity already that it can explore the maze and figure out, okay, this path leads in the wrong direction, or this path is not eliminated so far. It's still leading in the direction that I want to go. These types of learning tasks that are in some sense arbitrary, right? Like the maze is set up by the experimenter. There's no particular reason why the left-hand path should be better at leading to the food as opposed to the right-hand path. It's just the decision of the experimenter to try one or the other. So these are the types of situations that are sort of most suitable for the sort of empiricist form of learning through association. But even in this case, you still have to presuppose that the rat has some capacity of, recognizing the degree to which a certain path is leading towards the goal or not. And so he points out also that so within the same species, different individuals will have different capacities in relation to performing these tasks. Some of them are better than others at navigating a maze, for example. And then even with the same individual, the condition in which that individual animal is in, plays a role in determining how effective the animal will be at these tasks like navigating a maze. So if the animal is tired, for example, it's more likely to make more errors and take a longer time to learn the correct path through the maze, as opposed to the animal being fresh, well nourished, and so on, being in good condition, and then its capacity to navigate the maze and learn the correct path is much better. So what this shows is that the capacity that is exhibited by this healthy animal that's well rested and so on is something more than just this pure trial and error where the successful trials would be reinforced and bring about this sort of conditioned response and so on, this sort of empiricist version of the learning process. But instead, this capacity to learn the correct path through the maze is a kind of active capacity of the animal that can be exercised when the animal is in a good condition, but can be it is much harder to exercise when the animal is tired or hungry or whatever. It's this active capacity to explore the environment as opposed to just the sort of passive association of experiences that the animal undergoes. Obviously, human learning, reading philosophy is much different than a rat trying to learn a maze. But yeah, anyone who's tried to do study philosophy while working full time or something like that, you can acknowledge that it's much more difficult to read through difficult texts or try to understand what the author is saying after having worked all day than it is first thing in the morning on a weekend or whatever when you're not tired. This is not a very sophisticated observation, but just trying to study when you're tired is often not very effective. You find you have to read the same sentence many times, or you read something and you don't really grasp it, and then it's only when you come back to it when you're well rested that you read it again and it makes perfect sense. This just shows that even in this very sort of abstract form of learning in humans of trying to master a philosophical text, for example, the sort of basic physiological availability of energy in terms of fatigue or freshness plays an important role as well. So this sort of in one sense, reading a text is a sort of passive experience. Like your movements of your body are very limited, just your muscles moving your eyes from one word to the next and so on. So the expenditure of energy on physical movements is very limited. But at the same time, your degree of fatigue is an important factor in determining how much or how well you can actually grasp what it is you're trying to learn. And so the same sort of expenditure of energy or this role of fatigue is also at work in the case of the rats navigating the maze or any other learning task. And sort of in general, the fact that fatigue makes it harder to learn suggests, at least, or probably you could say it shows that learning is a kind of active process that the animal needs to actually do something to learn, as opposed to just this passive association of these atomic experiences with each other that would happen sort of mechanically and without the animal actually having to do anything. Yeah, I mean, the question. Yeah, so the comment here is about the Meno in Plato. So this, I mean, for Plato, of course, in some sense, you're not actually learning anything. You're just having your reminiscence of your soul's acquaintance with the forms before you were born. But at the same time, we see in that dialogue, for example, that the slave has to has to sort of undergo the questioning from Socrates. So his attempt to double the square, if I remember correctly, his first attempt is just to double the sides, which of course produces 4 times a square 4 times the size of the original square, and not double the size, which is what the original problem was. And through Socrates' questioning, the slave figures out that that the first attempt was incorrect. So again, we see here, even though the obviously this is a very different type of learning and different type of environment in terms of what kinds of feedback you're getting from, whether, determining whether your response was successful or not. Here, we still see that the learning process is something active. Even this reminiscence of the forms is a kind of active process where you have to, respond to the questions and figure out, is my first attempt successful or not? So you still have to, be actively involved in the learning process, even if the learning is something like a reminiscence of the forms that the soul was acquainted with before being born.
Yeah, and interestingly, the slave actually learns some geometry, but I think the implication is that Mino doesn't learn anything by the end of the dialogue. And I guess this is kind of borne out by the actions of the historical Mino betraying the Greeks in that Persian expedition. But yeah, it's Mino throughout the dialogue just kind of repeats what he's heard, I think, Gorgias, and just asks Socrates for definitions and seems to be unable to participate in dialectic, which is why he never kind of gets this vision of the whole, which requires this active participation. And these parts remain unconnected for him.
Yeah, I mean, obviously, the type of learning that happens in these dialogues is much more complicated, much more subtle. In some of the dialogues, what seems to be the outcome, what people seem to learn, is just that they don't understand something. These aphoretic dialogues, and so that can be a type of learning as well. You can start out by thinking, "Yeah, I know what virtue is," and then after going through these questions and trying to answer them, you sort of come to the realization that actually you don't understand it, and so that can be a kind of learning as well. But in each of these cases, like in certain dialogues, there are people that do engage in the process with Socrates that are sort of cooperative in the sense that they try to answer the questions and they're sort of actively participating. And then you have other people, often it's the sophist or someone who is sort of the target, Thrasymachus or whoever, this person that Plato is sort of criticizing, who thinks they know very well what the response is, and they have sort of a preset speech. And then when Socrates starts asking questions, they say, "Oh, Socrates, you don't understand. You're just not intelligent enough," or whatever. And they don't actually learn anything through the dialectic process. So here we see that the person in this situation has like a preset response, almost a mechanical response of like, if someone mentions virtue, then use speech 1, and if someone mentions knowledge, then use speech 2, etc. You could like it's sort of a ChatGPT type answer where it's just sort of keying off of these words and producing a set speech. So these are people who are not actually learning anything and not actively engaging in the process. Whereas other people, often these are people who are like presented as like students or young people, or like in the Meno, it's the slave who don't think they know anything or don't think they have knowledge, but by engaging in the dialogue with Socrates, they learn something and come to understand something better than they did at the outset. So again, this is a very different kind of learning than the rat navigating the maze, of course, but it still demonstrates this kind of active role of learning, that you have to actually do something to learn, and it's not just this sort of passive association of one stimulus with a certain response.
So reflex theory is true, but only for sophists.
Yes, that might be the takeaway here. Let's read one more passage and then discuss and end there. So yeah, if you could read the next bit from 101.
Yeah, it's the one that starts with even in these cases?
Yes, exactly. Thanks.
Okay. Even in these cases, least favorable to our interpretation, either the quote-unquote trials involve no internal law, but then they never result in learning, or there is learning, in which case the organism must be capable, on the one hand, of creating relations among the different possible quote-unquote solutions, and, on the other hand, among all of them and the quote-unquote problem, by which their value is measured. Even when the relation of signal to goal is a relation of pure succession, as happens in Tolman's experiment, we can presume the learning does not consist in recording de facto contiguities. It is necessary that the succession in itself, en soi, becomes a quote-unquote succession for the organism. This is possible in Tolman's experiment because the curtain, the alley with its signals, and the goal together enter into a spatial structure which has a meaning. But if one accustoms a cat to obtaining its freedom by scratching or licking itself, the animal reduces this movement little by little until it becomes imperceptible and does not renew it in case of failure. If it is a question of obtaining a piece of food by a gesture which is without objective connection, with success, the animal in executing the gesture does not look at the goal. If, on the contrary, there is a relation which we will call logical between the conditioned stimulus and natural stimulus, the animal does not take its eyes off the goal. One is clearly obliged to note that in the second case, the goal has acquired the power of evoking, in addition to the motor reactions of the visual apparatus, which in fact converge with them. Finally, the rhythm of the movements, their distribution, and their coordination in time are different depending on whether the response in question has a meaning and is related to the very essence of the problem, or whether, on the contrary, it is a stereotyped reaction evoked by an aspect of the situation which is abstract and external to it. Okay, so I guess that here what is talking about is basically that we can see from the different experiments that in the animal there is a sense of, I guess, meaning or logical connection, quote unquote, between the gestures that it does, I guess, trying to succeed to take the food, and like that on one hand, and on the other hand, you have the different behaviors that it does, which are just not connected to that task at all. And those behaviors, we can observe that the animal doesn't really do them with the same rhythm of the movements, or it doesn't do them while being fixated on the food. So it doesn't, we can maybe I guess, abstract away and assume maybe a bit too hastily that the animal doesn't think of those other behaviors as being behaviors that are connected to the goal or that will bring it about, whereas the first ones are, I guess, intentional, or maybe that's the intentional character of them is what is being, I guess, unmasked here.
Yeah, so like the difference here is between so you can think of like training a circus animal, for example, like, I don't know, training a bear to ride a unicycle or something stupid like that. Like, this is a completely unnatural response for the bear. It has no, like, the bear doesn't sort of recognize any connection between riding a unicycle and getting food or whatever. Like, there's no sort of intrinsic connection between the two. And so this is like the type of situation that the stimulus response theory is sort of most suited for. But this type of situation is quite different than, like, if you observe the animal in performing this type of very sort of contingent connection between a behavior and a response. The animal acts in a very different way than situations where there is some sort of logical or intrinsic connection between performing this behavior and getting the results that is desired. So like, just the one difference that he sort of highlights here is when you sort of train an animal to perform this unnatural behavior, or this behavior that has a very contingent connection to the reward, food or whatever it is, the animal just sort of does the behavior in this very sort of I don't know how to describe it, but it's sort of like goes through the motions kind of thing. It just does the minimum required to sort of fulfill this obligation so that it can get the reward. Whereas in the case of the animal that sort of grasps some sort of intrinsic connection between performing this behavior and receiving the reward, it will, for example, stare at the reward while it's trying to manipulate the stick to get the banana or whatever. It will act in a much more sort of decisive manner. And if you just sort of observe the animals in these two different situations, the whole sort of way of performing the behavior is very different. So it's this sort of, I mean, obviously this is not a very scientific description, just saying the rhythm is different or whatever, but it's just a much more decisive way of performing the behavior, as opposed to just sort of doing the, checking off a box because they've just learned somehow that doing this weird behavior that doesn't make any sense just happens contingently to bring about the results of getting the reward that they want. So yeah, it's the difference between grasping an intrinsic connection or a logical connection between performing a certain behavior and getting a reward on the one hand, and learning these contingent arbitrary associations between performing some behavior and getting a reward on the other hand. And so the way the animals perform that behavior is very different in these two cases. So Angus's comment here is it sounds a lot like working life. Yeah, so a lot of us in our jobs, have some sort of task that we have to perform, not because it makes any sense or like contributes to whatever goals we're supposed to be achieving, but just because our organization says you have to perform this, you have to fill out this form or whatever, and you just have to do it, just because that's the rules. It's again, there's like this very and then in these situations, of course, the people who have to are told fill out this form will tend to do it in like the sloppiest and quickest way that they can get away with, and not sort of devote any energy or take care of like how to do it. Whereas like if you're someone who actually cares about your work, and you see some sort of, you understand performing this task is important to achieving the goals that I care about and want to achieve, then you do take care to make sure you're not making mistakes and so on. Even in the case of human behavior, again, it's very different than training a bear to ride a unicycle. But even in this case, you can observe a difference in terms of like which tasks do the people like try to get through as quickly as possible and devote as little thought and energy as possible to, versus which tasks do they treat as like important contributions to achieving a goal that they care about, and those ones they'll like take care to perform in a careful manner and make sure they're not making mistakes and so on. Again, there's like sort of parallels in the case of human behavior, even though of course the setting is very different. I'm wondering, like in some of these experiments where like you're getting a monkey to like, I don't know, press the red button and then pull the green lever or whatever, and then a banana descends from the roof. Like, does a monkey like sort of understand like this is stupid? Like, why do I have to do this? Like, this doesn't make any sense. Like, are they sort of, do they have some sort of grasp of how arbitrary and silly the situation is? That's it's sort of what like something, obviously that's a sort of anthropomorphic description of what's going on, but something like that is what Merleau Ponty is suggesting here, that the animal like sort of at some level recognizes the difference between these sort of arbitrary contingent relationships between performing this behavior and getting the reward on the one hand, and then these other behaviors that have a logical connection to getting the reward on the other hand. And so like at some level the monkey like recognizes that this behavior has no intrinsic connection to receiving the reward, and that's why it does it like as it continues these trials, it sort of does it more and more superficially. It does like the bare minimum that it has to do to actually check off the box of having performed this task so that it can get the reward. Okay, so we can I think stop here unless we have any other comments or questions before we wrap up. Right. Okay. We will pick up from where are we? Page 101, I think. Yes, page 101. So we'll pick up from there next time. And so thanks everyone for coming out. Thanks for your contributions, and hope to see you next week.